Good morning. Good morning and welcome to the Industrial IoT Tech Talk with Moxa and Robotron. The topic today is monitor smarter, not harder, an IoT approach to low voltage monitoring. And the presenters today are Ronnie and Bobby from Robotron in Dresden. And my name is Hermann. I'm from Moxa Europe in Munich, and I'll give you a quick introduction. Here's the agenda of today. We'll talk about Moxa and IoT very briefly first. Then, for those of you who don't know all the details of what Robotron does, the Robotron team will introduce the company and then primarily focus on the solution that we want to talk about today, and then do a demo. At the end, we'll have a Q&A session, so please do ask questions. You can do that throughout the webinar in the questions section of the tool, and we'll get to them at the end. So by the end of the webinar, hopefully you'll know why we suggested the title Monitor Smarter, Not Harder, because the Robotron team did actually do a really good job at solving a problem that will be more and more important going forward, namely the low voltage grid and how you can add additional producers of energy, power generated by solar and wind farms, for instance, or installations, and then adding consumers that were not there before, like electrical vehicle charging stations. So the next few years, I think we'll see a lot of use cases for that particular solution. So before that, let's talk about Moxa and IoT really quick. Moxa has been in IoT before it was called IoT, you could say. So we've been working in the industries that you see on the left. We make industrial networking equipment, edge connectivity equipment to bring legacy devices to the network, and then industrial computing products from very small gateway type products to edge computers of fairly significant size, but all in the industrial environment. So we like to say we're focusing on reliable and secure connectivity between sensor and cloud in those markets that we choose to play in. We provide the infrastructure, but we don't solve the IoT problems of our customers alone. So our ambition is still to make it easy and fast for our customers to deploy IoT projects, so the data scientists can see if the data justify the business case. And if it does, we want to make it easy to scale. And with that, we probably have a number of hardware products that help with that. But on the software side in particular, we need partners. And this is the portfolio of partners that we have. Sensor partners at the bottom. You'll see AD-Tech power sensors in the demo. They will be on the website soon. There's a website like this as well. We have software partners. Robotron is probably our oldest IIoT partner in Europe. We've been working with Microsoft as a cloud partner for a very long time. And the other type of partners that are maybe not so obvious, but really crucial also in this type of project are the IoT service partners. And on the right-hand side, you see a few names. Sphinx, for instance, Sphinx Computer was the one in this project. So let's have a look at what they did and what our IoT service partners can do in general. It's basically providing that zero-touch provisioning experience to a customer. So they're close to the customer, they speak the local language, and they can add complementary products like sensors, in this case, the AD-Tech sensors. And then the key thing is they can take the standard Moxa product, put the software from Robotron, in this case, the RoboGate software, put it on the gateway, configure it, make sure everything runs, put the credentials in. So in the end, when the gateway is shipped to the location where it's supposed to be used, it just needs power and internet, and it starts to connect to, in this case, the device center software of Robotron, and it starts to work and can be managed on an ongoing basis from there. So nobody needs to be there with a laptop and configure it. Okay, so that's so much for the IoT infrastructure part. Now let's see what the real story is about this project on the Robotron side. So over to Dresden, please.
Welcome also from us today's webinar. My name is Bobby, and I have been working as technical sales consultant for Robotron for 5 years, mainly in industrial area with many topics around Microsoft, Azure, and industrial IoT. Today we are introducing you to a great IoT solution. Here is our agenda. First, a few words about Robotron as company. Then we come to a crucial building block for our IoT solution, the RoboGate. After that, we will have a short introduction to our net monitoring solution, where Ronnie will start with our live demo. Very briefly, a few words about Robotron as company. We started as a software service provider in 1990 with 25 employees. At that time, with a big focus on database technologies. Today, we have almost 450 employees in the company and nearly 600 in the Robotron group. Our headquarters is located in Dresden with almost 400 employees. And we have other subsidiaries and customers worldwide. For several years, we have been a Microsoft Gold partner with highly innovative topics around industrial IoT. This also includes the NeMo solution, which we presented today. As company, we focused with our products and services the energy sector for power and utilities, the industry with focus on the manufacturing automotive verticals, and also the public administration sector. Here's a small selection from our industrial portfolio. We are an experienced solution provider for industrial connectivity and edge computing. In addition to gateway solutions, we also work with machine learning and deep learning applications. For example, we offer a complete computer vision platform. Our solutions are characterized by high flexibility and hardware independence. Nevertheless, we enjoy working with hardware partners such as Moxa. We can use their high level of experience here. Now let's start to a short look at our product RoboGate, which forms the core for data integration. The slide shows an overview of standard components of our gateway software. It runs on various operation systems such as Linux and Windows, or completely virtualized as Docker container. We offer the connection of sensors or PLCs from automation technology with a lot of edge logic up to the sending of data to a target system, for example using MQTT. All these components in our edge software can be easily configured via an UI. The UI can be used for any device or Docker instance. If you have a large number of edge devices and they have even distributed across many different locations, we offer a fully integrated central device management solution. The so-called device center runs on premises or on the cloud, and you can use it to centrally manage all devices and instances. All these components are used in our net monitoring solution. Now let's take a look at the net monitoring solution. This is called NeMo, the acronym for net monitoring. Basically, it's about retrofitting the low voltage network, because currently all network operators are blank here. Only at the medium voltage level is active monitoring taking place today. So what we do achieve with a low voltage monitoring? Today our solution can already perform condition monitoring of individual local network stations and capable distributors, but also charging station infrastructure. Here data on the utilization of individual feeders is obtained by measuring power, current, voltage and frequency. The local network stations are only visited every 6 years. Up to now, there is usually only a track indicator that stores the maximum values. The second use case is very interesting. This is aimed at predictive maintenance. For example, detect an approaching short circuit or an imminent overload. And last but not least, forecasts and simulations are highly interesting for the current topics. For example, the electromobility and feed-in through photovoltaics should be named. Here you can simulate future events and make forecasts to organize the exploitation of a low voltage network in the future. Because today, no one knows whether the networks will be able to meet the requirements of electromobility. What are exactly our components of our solution? We offer a complete software as a service solution with retrofitting hardware. This means that we bring everything from hardware, such as sensors and gateways, to measurement and log the data. Finally, the data is sent to the Azure cloud and analyzed there with using the Azure Data Explorer. In addition, we have a fully integrated device management for the gateway in the field. This allows us to centrally manage, reconfigure, and update the complete hardware. For example, with a firmware update. We use the application as a web app for different roles and use cases. Here we use the current HTML5 standard and extended the application continuously with new dashboards and functions. Now some more informations on the hardware. The hardware is a very low-cost solution and consists of robust devices and our own Robogate software. We developed the software in industrial projects for connecting plants and machines. For the data collecting, we use inductive sensors and send this data to the Moxa gateway via measurement data logger. The connection to Azure is realized via LTE, so that the data is directly at the IoT hub and can be processed by our application. We offer the hardware together with our software as a bundle. We can measure up to 12 outlets with one bundle. To round off the topic, of course, we have already a great customer reference with MITNETZ. In the first project phase, 23 local network stations were equipped. The data can be read out every second, and our customer gets a first insight into the low voltage network. The application runs as software as a service on Microsoft Azure. Also, a project for the connecting of another 100 stations will start soon. The expansion has just begun. Now Ronnie will give us a live insight into the solution. Be curious.
Thank you, Bobby, for your introduction. And now we want to show you in our live session a realistic use case for the power monitoring in local network stations. Therefore, we have built up a demonstrator network station with a three-phase power line. At the power line, we have three power transducers. The power transducers are connected with the AD-Tech data logger, and the data logger is connected via RS485 with the Moxa gateway. And on the Moxa gateway is running our field gateway solution, our Robogate. On each line, we have consumers, an electric kettle, an heater fan, and here a laboratory power supply. Now we want to show you the use case, and for a better understanding, I have prepared a scheme of the configuration we want to do today. What you can see on the slide is we use three modules. The first module is the Modbus input module. The second module is the processing module. It's the stream processing module. And the third module is the Splunk module. And we do the configuration in 3 steps. First of all, we want to have raw messaging directly from the Modbus input to the Splunk output. And the next step is to configure the stream processing module. The stream processing module, we want to show you that we can do an filtering or an aggregation of data. We want to do an standard deviation calculation. And the third part is trying to create an alert if the power increases in a high way. And therefore, we are using the evaluator block of the stream processor and the rule engine. So now let's connect to the Edge Gateway UI. On this UI, you can see an overview of the modules. We are using the Modbus module, and for the Modbus module, we have different options. We create new, we have a server. The server or the master, we have to give a name. We have to switch the protocol variant and to set up the baud rate and the data bits and stop bits. After we have done this, we save the configuration, and then we have to define or create these slaves. We have one AD-Tech today in our presentation, so we have to create one slave. I've prepared it before because it lasts a little bit longer, so I will only show you how to do it. We have a slave name, and we have different groups that we can set up. The first group is the setup group. It does an initialization of the slave device. Here we set the baud rate and values for the current transducers. At the next, we have poll group and subscription groups. The poll group is for an equidistant data acquisition, and subscription groups take the values only on change. Today, for our demonstration, we prepared a poll group with 1000 milliseconds, about 1 second interval. The name is poll group or my poll group. And what I have to mention is that each module is connected by so-called edge topics with each other to publish the messages that are collected and created to the other modules. And so I have to define an output topic or an edge topic that is named data. And here you can see the registers of the Modbus device, of the AD tag, which we want to read out. And the power of each phase, the current, the phase voltage, and the frequency. So we can do a test run, for instance, to collect the phase voltage. And as you can see on phase 1, we have 233.4 volts. So next, what we do is to configure the output module. And as I said, I've also prepared this because we use Splunk today. It's an analysis platform for big amounts of data. And there we could have an easy analysis of the data and also an easy visualization. I have to set up the URL and the access token. And what I have to set up is also the edge topic where the data is published. And here you can see I use the data that I've configured in the Modbus so that the messages are sent to the Splunk. Now we can have a look if it runs. Here I go to the Splunk dashboard, and the scope is my poll group. And now we can have a look if we got values. So here you can see that we have the message. When we have a look at the raw message, then you see that it's an JSON-based format of the message, and the messages at the RoboGate have a header and also a body. And the header consists of source and scope. The source is mostly the module or the group of the module, and the scope is the single poll or subscription group of the module. And this is why I used scope, my poll group, to figure out the data. I've also prepared a dashboard so that you can see the current, and on phase 1, the current is actually 0.3 amperes. And the active power is 62 watt. So what we have demonstrated is now a raw message sending of the data. And what we now want to do is to aggregate the data. And therefore we are using the stream processor. The stream processor is an aggregation and data manipulating module, and it has inside functional blocks, different functional blocks. And today we want to use the aggregator block. The aggregator block is a block where I can set up a window, and the window is based on samples or time, and I can here set up the size of the window and also the hopping. The hopping means at which samples or how many samples a new window is starting. And now I use the size of 25 because afterwards I want to set up a standard deviation. And the standard deviation, 25 values, are a good amount of data so that I have not so much uncertainty for calculating this, and I have a good evidence of the value that I've calculated. So, and I want to do it for the current L1 and current L2. I also have the possibility to do other calculations, for instance, the average, sum. I can also let me give the first or the last sentence. So the aggregator block has here an output topic that I use, but I have to do a step between. I have to use the template enricher because when I use the current L2, then it sends the data in this way, but I want to know that it's not named current L2. I want to have an indication that I have calculated the standard deviation, and this I do in the template enricher, but this would go a little bit too deep for this webinar, so we do it in a following webinar and go a little bit more in deep. Here I can manipulate the messages, I can manipulate the header, and I use a new header scope that is called statistics, and I use a new body, and in this template enricher I can use the key values and map them to another key. So now I map them to current L1 standard deviation. And what we can now do is to have a look in the Splunk dashboard. And as you see, I have created a new poll group. This is called statistics. And now, statistics. And what you can see, the L1 and L2 is now named as standard deviation and is also calculated. The current L2 is 0 because I have no consumer on switched on. So also I have also built it in the visualization in the dashboard. As you can see here, I have the last hour standard deviation of the currents monitored, and here are the value of this. So the next one I want to show you, I have also the possibility to create an alert with our stream processor. And therefore, I use two further blocks, the evaluation block and the rule engine block. What I have forgotten to say, we have also an input switch. This means I have to define target blocks using the source and the scope for defining where to which processing block my message is sent to. And now here I have a filter, it's a regex expression. For the source, I want to have every message, and for the scope pattern, I use my poll group. Exactly this expression. And then I want to send it to the aggregator block that we used before and also to the evaluator block. The evaluator block, I can make Boolean expressions, for instance, or other calculations. And what I've done here, I created a new key. It's alert active power monitoring. And this value is calculated when one of the active power values is higher than 1500 watt. And the value can be true or false. And I have the possibility that each message that is here created can be routed in another functional block. And this I can do here. I send it now to the rule engine, and at the rule engine, this is a really mighty block where I can define rule sets on several conditions and can manipulate the data on this way. And here I have set up 2 rule sets, and there I look if I have the body of my message, in my body of the message, and true of the active of the alert active block. And if this is true, then I send a message that is called alert active power monitoring. And here below, you have so-called message templates, and this is one of the message templates. And there I can define a whole new message that with the content of the input message, and then I can send them forward. And what we do is creating a new message with the active powers of each phase, the active the alert active power monitoring bit, and timestamp. And here I can also create 3 values. So, and here I have to map it on the output topic. This is go on, and the output topic is mapped to the edge topic to Splunk. And here I configured the output topic to Splunk. And when we go back to the stream processor, having a look at the rule engine and at the message that I created, we have a source that is called stream processor and a scope that is alerting. And now we can make a demo of the alert bit, and therefore we use the scope alerting. And what you can see now, the active power of L1 is 63 watt, and the alert power monitoring is false. And my value is 815, as I put in my message. And now I can switch on one of my consumers to see that it will running. I use the heater fan. And first of all, you see that the active power is switching on to 1000 watt, and the active power monitoring is false. And now I use the second level of the heater fan. This uses 2000 watt. And as you can see, now the active power monitoring alert bit is switching to true. What I have done, I have also visualized it in a dashboard. And here you can see that the active power alert is 1. And when I switch it off or to step 1, then it switches to green and to 0. So this was our demonstration of the flexibility of the Robogate software powered by Moxa. We hope you enjoyed it, and we'll give back to Hermann.
Thank you very much, Ronnie and Bobby. I really learned a lot, actually, even though I've been, in touch with that project for a very long time. Thanks a lot. We do have a few questions, but if you like, you can also switch on your camera if you can again. I know it's a different system now, but Oni Bobby, if you, very good. I can't see it so well, but I think it looks okay. Very good. So I have a few questions. I will go through them from more detailed to more general. So one question was, how many outlets can you monitor with one such bundle?
Thank you, Hermann, for the question. With one bundle, we have, or at one bundle we have one AD tag inside actually, and with one AD tag we can monitor 4 outlets. This means one outlet has 3 phases, and we have 12 inputs, and so we can handle four outlets.
Okay, got it. If this didn't answer the question enough, then you can ask follow-up questions in the chat or in the question section. Another question: can I use devices with different baud rates?
Yes, you can, because our Modbus module has different servers that can be configured, or masters that can be configured, and the Moxa device, the UC 8112, has 2 serial interfaces, and so it is possible to use 2 Modbus networks with different baud rates.
Great, thank you. Let me check. Okay, then one more cloud but specific question: does it run in a customer or Robotron Azure environment? So is this you who owns the data, or can it be the customer, I guess, is the question behind it?
The data is owned by the customer, and when we use, for instance, at our reference customer for the MITNETZ, they have their own cloud subscription, their own Azure subscription, and the data is sent from the Moxa device via LTE to the IoT hub, and this is the input for the Azure cloud for the IoT data.
Okay, so basically you're open to work in the customer's environment, or I guess like in this demo, you're also happy to run it in your own.
Of course, also when it comes on premises, so then we have the possibility to use different broker systems, for instance, MQTT, or also the Kafka broker. Also, it depends on what the customer needs.
Okay, then last question I have here. I think, would a similar approach work for monitoring energy consumption of large buildings or other big commercial or industrial buildings, or locations, let's say, factories?
Yes, of course. We can use and adopt this solution in an easy way, also to buildings, to subnets in buildings, to supervise single machines, or the outlets for single machines, and also for subnets that are in factories or something like or bigger buildings.
Okay, I thought so. Very good. Okay, I think that's the last question. There's one last thing I want to show. So I'll try to share my screen again now and show you where you can find. Show my screen. Can I show my screen? Very good. Sorry. I want to show you how to get in touch with us. So if you have further questions, I hope you can see my screen now. Can I? Can you? Okay. So this is the Moxa IoT page that was mentioned in the slides at the beginning. And if you go down here, you find the different partners that you saw before. And if you go here, at least that's one way to get here. You see this particular use case described on the website. I think today you learned a lot more, but the key thing I want to show you is who to get in touch with. So obviously, you can contact any one of the three of us, or René or Marco from Moxa and Robotron, respectively. And if you're interested more in the details of what actually the business side is, what MITNETZ is doing and why they're doing it, and everything about their new tariffs around, that are more dynamic and flexible than before. It's in German, but here you can see a lot more detail about it. So if you have any questions or would like to see something more specific, get in touch. And Ronnie, Bobby, any last comments about the project or any of the questions?
Yeah, thank you, Hermann. From our side, that we have the possibility to present our solution, and yeah, it's great to work with you. Thank you.
Likewise. Thank you very much. With that, thanks for attending, and you know what to do if you want to get in touch with us. Thanks a lot. Bye-bye.
Thank you. Bye.
Bye.